the last panel discussion of Now Disease Symposium 2023. I hope you enjoyed it so far, but it's not the end. There's still a highlight to have, and that is the developer perspective on opportunities, near-term opportunities on innovation. And my name is Jan Matthijs, and I'm a director at the Carbon Trust, but I'm also chair of Now Disease R&D committee. And the R&D committee are experts from our member companies in our DC who are directing the research priorities, the research needs of this consortium. And today I have the pleasure to have a very knowledgeable panel on the stage here with me, and I will ask them to introduce themselves in a minute. But what I would like to do today in the next hour is to structure the discussion into sort of three key challenge areas, and then have a discussion with the panel and with you as well to explore how innovation, how technology can help us to address these key challenges that we are facing in the industry. So I want to talk about supply chain and scaling up the supply chain, which is needed urgently. I want to talk about grid integration and how do we get more power into the grid infrastructure. And I want to talk about floating wind and the innovations that we need to see to really commercialize and scale up floating wind technology. Let me ask the panel to give a short introduction and maybe also a quick outline of the projects that you're doing in the US, and also what you think is what the role of innovation in this sector. And maybe I can start with you, Colwyn.
Sure. Hi, everyone. I'm Colwyn Sayers. I serve as Offshore Structures and Geosciences Engineering Director with EDF Renewables North America. I've been with EDF for all of 9 months, so I'm still relatively new to the developer world. However, I've been involved, connected with, worked in the wind industry for quite some time. Prior to joining EDF, I was with GE, developing wind turbines for 15 years. So EDF, as most of you know, is EDF Renewables North America is a subsidiary of a broader EDF company. We're responsible, EDF Renewables is responsible for delivering renewable energy to the global grids. And we have currently about 18.5 gigawatts of install base from a renewables perspective, of which 11.5 gigawatts globally is wind. And of that 11.5, a little over 1.5 is offshore wind. In North America, we are connected and deliver offshore wind through the Atlantic Shores Offshore Wind Consortium, which is a JV, a 50-50 partnership with Shell New Energies. And we have 3 lease areas off the coast of New Jersey, and currently are delivering the 1.5 gigawatt project, which is Offshore Winds Project 1. EDF is committed to delivering offshore wind in North America, would love to continue to develop projects and continue to explore opportunities as such. We'd like to drive some stability within the supply base. I think that's a really important one for the success of offshore wind in the US. And we're very committed.
Thank you. And then over to you.
Thank you very much, and nice to see everyone. My name is Helene Austevoll. I'm with Equinor, and I've been here in the US for about 1.5 years, but with the company for almost 20. Equinor is a broad energy company. We aspire to be a leader in the energy transition, so we have a portfolio, of course, based on our oil and gas portfolio back in Norway and the Norwegian continental shelf, but expanding into all really areas of renewable energy, and both within CCS, hydrogen, solar, and on and offshore wind. So we have about 50 years of experience with offshore projects, 10 of those with offshore wind. And we want to be, and I think we are, a values-driven company with a clear vision, and we want to, that being clear in all our developments and our choices that we make also. So that's also why we have been very clear, I think, in setting this direction, where we want to invest heavily in renewable energy and be a part of that transition that we all need and are looking for. On the US side, so we've been here in the US since the mid-'80s. We have an office at Stanford at the moment. We've been there since 93, I think, so quite a while. And we're expanding within renewables in the US at the moment. We have 2 lease areas here outside of New York. And then we also have a lease area looking at floating outside California. For me, I don't think I said, Deputy Project Director on our Beacon Wind project, which is a lease area that is about 60 miles east of the tip of Long Island, 20 miles south of Nantucket. And there we are developing about 2.3 giga from that area is what we're looking at. When it comes to innovation, I think maybe what we're all looking for, right? Having to stop just growing in size and first timers of things. And I think it's perhaps time that we try to consolidate on some solutions so that we're able to industrialize also and make mature, efficient projects that are profitable and that will deliver the renewable electrons that we're all kind of looking for. So yeah, thanks.
Excellent, thank you very much. And Enrique, over to you.
Hi everyone, my name is Enrique Bosch. I'm the head of corporate innovation at Avangrid. Avangrid is a renewable energy company here in the US. We are part of Iberdrola Group. Iberdrola is a global utility with operations in 6 continents. I think right now we are the second or third largest utility in the world, and the first wind producer. Here we got, like I said, we are Avangrid. We got 2 main business. One is utility. We provide utility services like electricity and natural gas to our customers, mainly in the Northeast, through 8 operating companies. And then the renewable business is we develop renewable energy projects, solar, wind, onshore, offshore, hydrogen, and battery storage, and we are present in 24 states. I think here in the US, our main project right now in execution is Vineyard Wind, which is, let's say, the first commercial scale that is going to be hopefully up and running next year, in 24. There is a couple of turbines already installed. They should be providing electricity before the end of the year, in a few weeks. And I think that's, we are very excited about that project. It's 800 megawatts. I think it's 20 miles south Martha's Vineyard. And then in terms of offshore wind, we have also some other areas. We got other projects under development up to 6 gigawatts in development: Kitty Hawk, Commonwealth, and Park City Wind. So the vision of Iberdrola and Avangrid in offshore wind, similar to other developers, we made the bet, at the beginning, first movers. We are aware of the complications that with the COVID and supply chain disruption we had in the sector. But we are confident that these projects are going to be profitable, and we're going to be able, between all the different developers that are working in the US, we're going to be able to develop the market, the supply chain, and the vendors and the collaborations to really, as you were saying before, to have a little bit of stability and be able to enjoy a little bit more this project. But yeah, I think that's in a bit.
Excellent, thank you very much. So you can see there's a lot of experience on the stage here with me, and companies that are really innovative and also truly global. So it would be good to discuss, go a little bit more into the sort of nitty-gritty of the innovation needs. If you want to join this discussion, just use Slido as you have done in the other sessions before, and I should get messages here. But let's start with supply chain, and looking at the sort of ambition that we see in the industry, not only in the US, but even globally. We have now around 65 gigawatts of offshore wind installed globally. We heard numbers of 250 gigawatts by 2030, even higher earlier, 300 gigawatts by 2030. So we need to really scale up offshore wind, and that needs to happen quite fast. So that is also a challenge for the supply chain. So how can technology help the supply chain, also considering that we need to scale this up in a sustainable way, so we need to see further cost reduction happening. How can we do this? And Ellen, maybe I can start with you. You used the magic word of industrialization earlier. Do we need to industrialize the supply chain, and if so, how are we doing this?
Yeah, very good questions. I definitely don't know if I have the answers, but I can, say something about our thoughts on it. And it is that, I think us as developers definitely have to push for this standardization as well, right? Because we're very often pushing for bigger, stronger, longer, higher, everything, right? And that won't go away in terms of that we need, we need more power out of these machines. But perhaps the answer is not more muscle in a way, but perhaps it's kind of more brain, so to say. How can we stop pushing for these larger sizes, but how perhaps together push more for, how can we make it more efficient or more effectful or smarter or lighter or, materials or tools, so that we're able to make this and industrialize and standardize at least the major components. And looking at our projects, the major cost drivers, of course, are these, of course, the turbines, the foundations, and then as a consequence of that, also, of course, vessels and installation parts of this. And if everything needs to be custom built for every single project, it's not going to, be an industry that will survive. So we definitely have to, standardize, I think.
So we need to industrialize, we need to standardize. How about what is a way to get there? I don't know, views from the others?
Yeah, I think that's the key point here. So to really grow the industry, you need to standardize, you need to modularize, to make models and be able to scale up. We don't need to have 10 different designs for every component. We need to have 2 or 3 that really work, that we can interchange, that we need to define the standards. If you think about it today, there are not many vendors for the components that we use in the offshore wind projects. There may be like 2 or 3 local or relatively local, because when I say local, it's US plus Europe. We need to have more. We need to have also more stability, so these vendors can develop supply chain. So first of all, and I know it's difficult, our projects need to be successful. So these vendors and the supply chain can build locally, the manufacturing facilities, the ports expansions, everything that is required to really be competitive. If we don't, as developers, we are not successful in that job, the vendors, the supply chain isn't going to come back behind and pushing and developing all this that is needed. So we need to provide that stability. And then, I think the key points was Ellen was saying that we need to standardize everything. There's no really standard. So it's everything. It's a custom tailor suit for every project, and I see this in other areas in other sectors. For example, when I see in solar, I see that the exponential growth that solar has lived is because there was a lot of innovation in the supply chain. Of course, there's always innovation in the technological components, so new materials, which is always essential, and probably they're going to be similar in the offshore wind. We are looking for new materials and things like that, recycling and everything. But I envision a lot of innovation in the supply chain, how we modernize the process, how we put robotics in the supply chain to make really something faster and more efficient.
Colin, you have a view on this as well.
The only thing I would add, everything Enrique and Ellen just said, but I will definitely add the need for more joint industry projects to identify the places where we need to standardize. It is recognized that developers are in a competitive process, right, to be able to develop these sites. However, I think, you can't standardize everywhere because then we all share all of our information. However, we need a concerted effort to identify where we need to standardize and where we need to share information. So I think, GIPs is a good way of doing that. I know there are a number of GIPs that Carbon Trust sponsors and supports, but we definitely need more of those to take the next step.
Yeah, good points. But there is also a little bit of a tension because innovation is obviously important, and innovation drives the industry forward, achieves cost reduction, and there's sort of a tension between standardization and innovation. How do we ensure that if we standardize everything, industrialize everything, it slows down innovation and may also slow down the progress and of the sector? I don't know other views on this.
I think we can. I work in innovation, but I think we can live together. So I think we need both. We need to have clear rules about how we manufacture, how we deploy these systems. But at the same way, we need to be creative, and working in innovation, I always look for incentives from companies, collaborators, associations to do things differently. But I think both are completely, compatible.
Ellen?
Yeah, maybe I could touch also upon, right? There's areas within this industry that are very, the concrete and the sizes, and just say the blades, right? They're not easy to transport. And when you get a place like New York State, and think about the coastline and getting it to that, and transporting it. It's just size matters in this discussion. But if we're only looking at increasing size, after a while, it's going to be a lot of logistical issues. So I think finding solutions where we can be more efficient instead of just bigger will be very important for this industry to be able to also grow in areas that aren't kind of optimal for transporting huge components.
It's a good point. But maybe let me challenge you a bit on this one, because obviously scale has enabled cost reduction, and it really was one of the main drivers to where we are now. Colin, you work for GE, and just saying, okay, we should stop the size of turbines. Is this the right way? And if so, how can we do this?
Interesting question. So I think we should still be ambitious relative to driving, getting more bang for our buck, right? Out of each wind turbine generator that's installed, right? That said, I think we are moving quite fast. And I think we need to invest more in testing and validation. Because if you think about the physics of it, as you grow components, they behave differently. They break when we don't expect them to break. And our models, our current analytical models, aren't able to keep up with the growth in size, right? Not only that, but we also have to install these very large components. And, we keep cycling the different aspects of the projects, from design through installation, through operations. We keep cycling them through new components, new ways of doing things before they even get a chance to iterate. And you have to give them a chance to iterate, right? You have to stabilize. And in and of itself, we say growth is innovation, right? But at the same time, we don't give these other processes an opportunity to do their own innovation, right? Because that's how we learn. We learn from doing the same thing over and over again, right? And we find opportunities to optimize. So I think there needs to be two things. I think you need to give the supply base an opportunity to do their own innovation, stepwise innovation. And then the second thing is we need to invest more. I think it was a really good panel discussion yesterday. I think it was the folks that presented from Massachusetts, New York City, and New Jersey, where they are investing in testing and validation, and we definitely need to do that more. The last thing I would say on this is when we think of innovation, we always talk about innovating on functional needs, right? So delivering a wind turbine, installation, O&M, but I don't hear enough conversations, in my opinion, relative to innovating on testing and validation. The more we can improve our capability to test and validate, it would help us to weed out what doesn't work. And then that also drives standardization, kind of organically.
Yeah, I agree. It's one of my message to my kids is normally you learn fastest with mistakes. So you allow mistakes to happen in the right environment, and then you learn much faster. So we need to standardize. We need to invest more. We need to put more innovation into validation and testing. But then also we mentioned innovation in the supply chain, being more innovative in the supply chain. But what are the key innovation in the supply chain? What do we need to see? What do the supply chain need to invest in for the future to be more innovative? I don't know, Ellen, you have a view on this, to put you on the spot here a little bit?
Well, if I'm thinking of the supply chain then in kind of a larger sense in a way, I think we will always be looking for more efficient or more effect out of our turbines, right? As an example, but what are the limitations for that? And one is understanding. One thing is understanding wake or the wake effects, but the other thing is what do we do about it, right? So I've been thinking about, how can we make even smarter turbines? Can they talk to each other, say? Can they optimize in real time without using so much energy that they do today in moving around, right? Can we think of possibilities of getting more energy out of a farm by them coordinating with each other? Some of them moving, out of the way of others if they can, optimize. So I don't know the answer. I'm just challenging. Could we think of that instead of just, again, size, right? So yeah.
Yeah, I think in terms of supply chain, I think I mentioned before, one of the things is we need to modernize the supply chain, the manufacturing facilities, but that's something that is going to require a significant investment from the manufacturing or the vendor side, so we need to provide some stability. In other words, they need to invest in robotics, in machines, and all that is expensive, and they are not going to do that if they have a pipeline of projects to execute in the coast of Massachusetts for the next 10 years. That's one thing. I think in any case, supply chain is one area. Then Ellen was mentioning, there are a universe of things that you can do in innovation. Talking, the turbines, the wake effect is a big concern, something that we really need to understand better. I think data sharing is another interesting topic. So far, you got developers working, independently, of course. But at some point, are we sharing the data from what we are doing, the surveys that we are doing? Maybe we can save, a ton of money, or maybe we can just, sell that information at some point. But data sharing, I think, is another thing that innovation can help. And what else? Probably there's an aspect that at some point I think we also had to progress. I don't think I have it mentioned, is the engagement with the local community. So one of the challenges that we have, not just in these projects, but in general, when you install something relatively new, you need to engage really, well with the communities and explain the projects and make them, to participate and have a voice and a decision. Maybe we can use also some of this innovation and data sharing to share, the progress of the projects, the status, the benefits that are going to result. So far, that is being doing in of course, a structured and manual way. But I think there is a lot of these days with all the electronics that we have. I would love to have like an app just to report me, hey, this is the status of the project, this is how it's affecting my community, this is how many CO2 we are avoiding. So people is fully aware of what we are doing also. So that's another aspect, but there are many, in my opinion.
Thank you. That's very good. Very interesting. I just want to come back to standardization a little bit, because I covered a number of questions in the audience actually, and just to pull some of them together, I think it's sort of how do we achieve this? Is there a role for governments to do this? Do you have internal processes? Do you actually looking at this internally as well? And then also maybe just a final point is sort of, you mentioned data sharing, but you're also very much competitors. and standardization also is reducing potentially competitive edge because you are not unique. So how do we square this sort of role of governments, internal processes maybe, and this sort of competitive angle? I don't know, any views on this?
I think we have a lot of examples in other industries where competitors find ways to identify specifically where you want to standardize, because it's a trade, right? If you identify where to standardize, maybe you lose a little bit of competitive edge, but you gain a lot more in helping the supply base to, minimize the amount of customizations they have to account for, right? And there are a lot of examples of that throughout industry. I think, like I said before, I think we need to identify where you have only a small amount of competitive advantage, and then see whether or not there are bigger gains in standardizing in those areas.
Good. Anyways.
Yeah, I think very good points from everyone up here, and I think data is definitely an area where I think we can share more than we do, and I think it will help us as an industry. I think it's actually an overlooked benefit maybe from offshore wind to that we have these massive amounts of data that we're collecting on regional areas, and like us, we collect aerial wildlife data. We have 2 years of mid-ocean data, and all of that we have made publicly available to anyone, scientific communities, public, through our partnership with Maricos. So I think, and we're dependent also, of course, of data that's available, that's already been collected. So I think that can also, again, perhaps spin off into standardized qualifications of industry, like technologies, right? For perhaps, say, feasibility for a certain type of foundation for a certain region, based on collected data that we share, right? So that instead of it being everyone have to qualify their own type of foundation, would have a set of kind of pre-qualified for that area for that type of water depth and that type of ground situation, as an example.
Yeah. Thank you. Enrique, any?
No, I was thinking, just trying to find a parallel example. I was thinking that maybe, things like, when the developers RIA group and we are part of organizations, things like that, that's a very positive thing. That's a starting point, because it's when we start sharing some challenges and concerns and everything. I'm not saying that we have to share for free. Maybe the solution is to have like a mechanism or organization that allow us to sell part of our data to others, and maybe that's the mechanism. I don't know, but I was thinking that in the network side, we as utilities, we got the ISOs that regulate us and the way we participate. Like, sometimes when you are a generator, or sometimes when you are a distribution company. So maybe it makes sense to have some kind of organization or association that can guide the operators, or not the operators, sorry, the developers, in things like this. So how we share, how we connect, what is the rules that I had to follow to make this interconnection. There are many things that require a lot of consensus/discussion, how we connect, where we connect, from many point of view. So. But I think associations and alliance like this one is a good start.
So there could also be a role for NORDC, for example, to do that. So maybe we should move on to but supply chain, just to sum this up, industrialization, standardization, a key, more investment in innovations in the supply chain sector, more innovation and testing, validation, and more investment. That's probably what we're sort of looking at to really scale up supply chain faster, I think. Grid integration, another big challenge that we are facing. So we have lots of power that we need to integrate into the grid, and the grid wasn't really built with offshore wind in mind. So there are real challenges to do this, and we need to do this fast. Considering scaling up or upgrading grid infrastructure is a long process that doesn't happen overnight. So what are the sort of technologies that we need, the innovations that we require in this sector to help us get more offshore wind into the system? Henrike, you have a view on this?
Yeah, interconnection, I think that's the elephant in the room. So sometimes I hear people, fossil fuel companies criticizing offshore wind, for example, say, hey, how are you going to bring all that power? Yes, of course. It's one of the elements that normally is not addressed many times. So what I mean is that you have to invest a lot of money in transmission and distribution to bring any renewable energy technology to the grid, and that's evident. There are many ways. So transmission is a very slow process. Permitting is a nightmare. You can see how your projects are delayed and can take 7 to 10 years. We got experience about that. But at the end of the day, any new addition to the grid is going to have the same requirements. So to those people, criticizing a specific renewable technology because transmission or distribution, that's not new. So for every dollar you invest in renewable energy technology, you have to invest half or $1 in distribution and transmission. So that's what it is. Solutions. I think now we got, or innovation, I think we got more. We got smart grids. Now we can have a better idea about how our transmission lines are operating. Our full capacity, our 80% capacity, we can measure with more accuracy the status, so we can have better decisions. I think at the end of the day, for the particular case of offshore wind, one of the very basic things that I like from the offshore wind is that it's developed, of course, in the sea, but it's close to population, big cities. So just it should be an easy interconnection, and it's complicated to say easy interconnection because there is no easy. But what I mean is that we can add to the grid gigawatts of generation in very close to where they're going to be, the load is located. So far, again, I think the developers, we are working individually. So when we develop the interconnection process and everything, we are doing Avangrid is doing one place, Equinor is thinking another place. I think eventually what should be happening is that we can work together in define big transmission lines, close to the shore or wherever it is, to where all the developers can connect, and we can define like a transmission line in this side of the business. But I mean that's probably gonna take some time and probably some 2, 3, 4, 5 projects to be developed. But I think in the meantime, we got a lot of technology to read how the grid is behaving, what's the capacity, and then find the best way and the best strategy to connect or interconnect to the grid.
What information?
So I'm going to defer to Enrique because grid. I'm a structural engineer. But when I do talk to my my colleagues on the electrical side, on the grid integration side, I hear a lot of what you mentioned, including the need for a little bit more innovation, technology around how these grids that have been there for a very long time can manage this type of energy. So some innovation needed there as well. Yeah.
Ellen,
I think I'd comment a little bit on I think your points are definitely very good in terms of that we have to, I think, instead of every single developer figuring out where to connect some of these common ones that are already kind of set up for it. I think that's a good way to go. What I would comment on, though, is that connection point, right? And it might sound easy, but that is where we actually kind of meet people, right? Where we meet people's backyards and streets and schools and everything. And we have to, so I think in that space also, I think there's room for innovation in terms of the visualization of what we're going to do. How do we take down that fear that people feel that we're digging up the street or putting cables somewhere that's going to be hurting someone? How can we take down that fear and how can we inform in a good and clear way? And I think that with good visualization tools, that could be a very valuable tool for us to have a good conversation. And for us as a company, we've used these 3D twins for a long time in terms of training ourselves in operations and in very challenging operations that we're doing on either our fields offshore or in connecting. But it can also be used in communication purposes. And I think for this purpose, it could be very valuable.
It's a good point. It also came through the Slido, actually. Approaches community engagement and can we innovative solution in terms of community engagement. Henrik?
Yeah, I was going to add some point I forgot to mention before. One aspect I'm very enthusiastic about it is about energy storage coupling with offshore wind. It's not a new idea, of course, but it's something that it really excites me because I think we need to think about offshore wind as new capacity. We're going to build gigawatts of offshore wind, hopefully in the next decade. But if we are able to add some additional service, not just capacity, but if we are able to combine that with some level of storage, onshore or whatever it is, but as part of the project, so we can have, ancillary services, frequency regulation, other uses, different, and new services to the grid. I think that's a good way also to add value to the offshore wind project, not just heat. This is renewable capacity, 50%, hopefully 48%. But if we add, that component of storage, I think it's much more powerful. So that's one line of, innovation that I'm particularly excited, and hopefully developers, at some point we can start adding, the battery storage, but also the service to the grid. So our offshore wind projects can compete with the other, technologies in the grid at the same level.
Yeah, it's a good point. Also, if you think it's sort of, looking at energy, not just electricity as such, then hydrogen is part of the mix suddenly as well. And I was wondering, are you doing things around hydrogen? Is this something you're looking at to get more energy converted in a way and into the wider energy system?
We are doing in Avangrid right now. We are developing like 8 to 10 projects for hydrogen in the US. In Europe, Iberdrola has 2 plants up and running for green hydrogen. So one of our missions here is to replicate the model. So we want to generate or to produce green hydrogen from renewables, and of course, offshore wind is one of the aspects or one of the angles that we need to consider. To be honest, we have run a couple of studies with NREL and MIT and others. Maybe now is not the best moment to run economic numbers for offshore wind and hydrogen because offshore wind is still with the supply chain disruption and everything is not the best economics. But also hydrogen is in early stages. So I don't want to don't take any quick conclusion. But in my opinion, it's promising. So at some point, a way to deal with curtailment. A way to deal with green generation or even products like ammonia or something. If you can do that and you can produce or find a ways strategies to produce that offshore, that's interesting. So that's an angle that we definitely are studying. It's not something that we can say, hey, we're going to develop a project in the next 5 years. We are not there yet. We are trying to develop more conventional solutions for hydrogen, even though it's not conventional. But I think eventually, probably those paths can cross at some point.
Interesting. And then,
I touched a bit upon it, but we are definitely looking at a broad spectrum of possibilities, from CCS, carbon capture and storage, to hydrogen projects, definitely around Europe, both in Germany and in Great Britain. And we're, of course, solar and on and offshore wind. And in the very kind of starting phases, as I talked about, we have one lease outside California, floating wind. And in conjunction with that, looking a little bit at also floating wave energy with a startup out of Berkeley. So, if we can optimize somewhere where we're already putting infrastructure, right? That's also very interesting to look at. How can we take advantage of that time when there might not be that much wind? Is there other type of energy we can harvest in a renewable fashion? And
Excellent. I would be interested to learn a little bit more how you manage innovation actually internally. So we have heard, Innovation Hub. It's Equinor very much involved in this. Very good. Are there similar initiatives at EDF, at Avangrid, where you? And also, this is one aspect, but then also, how do you share knowledge and translate innovations between different markets? Because they are all very global. Challenges, technology needs may be different. How do you work with your subsidies? That would be quite interesting to discuss.
Yeah, so EDF at the parent level invests quite a bit in R&D. R&D, we have our own R&D organization where we continue to prioritize which technologies we want to continue to funnel funding to. Just involved in that process a couple weeks ago. Just finished that process going into 2024. So definitely trying to find synergies across different applications. Tend to prioritize those more, but definitely a significant amount of funding goes into our R&D team, and we support that strongly internally. And a lot of those, some of those projects are coupled with other joint industry projects as well.
How is it for the others?
Yeah, well, in Avangrid and Iberdrola, I like to think that innovation is everywhere. That's what, because I work in innovation, and I like to think that way. I think innovation has to come at different levels. So, for example, the people that really know about one particular topic, either if it's networks or offshore wind or hydrogen, it has to be the people in the business. So they have the knowledge, they have the day-to-day operations, they have the day-to-day collaboration with the vendor. So normally the idea or the improvement is coming from them. The way we are organized, we are a global company, and there are areas where we have more technology, more projects developed. For example, Iberdrola in Europe has a lot of knowledge, a lot of projects developed for offshore wind. So we are, as in the US, we are taking benefit from that knowledge to some point in the innovation point of view. So, for example, sometimes we coordinate some meetings, we receive some startups company that we should look into here, for example, or this experience or that. So that's definitely a benefit to be one of these 3 big companies that you guys have here. We can benefit from global experience in different territories. And then in Avangrid, in my particular case, we work a lot of globally. And then, like I said, business units have people looking into innovation. And then my team works in corporate innovation. And what we try to do is just to support that nobody's stopped in terms of innovation. So no opportunity is missed. If someone has an idea and is struggling to develop, they can come to us, and then we put the resources to that idea to be developed. If there is funding out there, and these days there's a lot of funding from the DOE available, we try to support those ideas, those projects, from with our resources to be able to catch a little bit of that funding and be able to develop a new project. So that's the way we try to support from Avangrid Innovation.
Yeah, on the Equinor, it's not too different from that. We have an organization that it focuses really fully on developing new technologies. They're divided into different areas. One area focuses on our kind of venture portfolio, where we are part of investing in startup technology. And there's no direct link that we will always use that technology, but why we invest would always be linked to what we think the industry or we will have a need for in the future. So that's one kind of leg of it. And then, of course, from the project side, we will always kind of pitch in to that centralized unit in terms of the needs that we see. And if it's a need that comes from several projects and something we can use across our portfolio, it's definitely something that will then be prioritized in the portfolio, which also helps us kind of with the qualification of that technology, so that it's not just on individual projects' responsibility to get that done. But again, it's a balance, right? Because you don't get in our kind of corporate portfolio of projects, you don't always get the highest score when you have a low set of proven technologies, right? If it's always a risk if you have very much new things you want to try out on your project. So it's a balance about incorporating the new, but also building out what we already have proven and know that we can deliver on.
Interesting. Also, maybe touching on how to get innovations into the projects. And it's good to hear that you all have initiatives. There's a question from the audience. Is there a particular phase that has maybe a little bit lower risk, where it's a little bit easier for researchers to get in? You mentioned earlier, Colvin, that the need for more testing and validation. And yeah, how do you, what is the right place within a sort of project life cycle to engage for startups, for researchers?
Well, in the case of Injar Wind, as part of the bid, there was some funding available for local engagement and things like that. So we engaged in this particular case with Greentown Labs, and we ran this year and last year one accelerator program. So We have multiple discussions with startups for offshore wind with a lot of different solutions like drones to monitor the turbines, technology to help us with the predictive maintenance, a lot of autonomous vehicles for inspections. So it was really really interesting. The result of those programs normally are it could result in a pilot, something that we eventually test. And then, I mean, I think that what is important is the whole journey. So it could be a pilot or not, but in the process, we have learned a lot from these startups. And we also have provided some feedback to them so they can develop better technologies for us and for others in the future. The other aspect that we use a lot is collaboration with academia and institutions like national labs, things like that. We do multiple studies with MIT and Tufts University and some others about specific problems or specific challenges that we have in our projects. I'm thinking about, for example, offshore wind. We did a project with MIT last year. It was kind of a very simple tool that helped us to predict the movement on the waves when we are, because of the Jobs Act, we need to put everything in one ship and then go to the sea and then change the things, right? So that tool helped us to predict if we were able to execute that activity in the next hour or if the weather is going to be really bad and the waves are going to be super high, so I have to stop. So normally, the collaboration with the academia and institutions could be like for some specific, challenge that we have to address, or sometimes are more, market level that we ask, NREL or someone to help us with the market analysis, for example, hydrogen production from offshore wind. So those are the kind of collaborations that we have in place.
If I could just add, I think it depends on the project phase. And when I say phase, I don't mean from a timeline perspective. I think it's easier to try and implement O&M related innovations as opposed to trying to implement something new in our design phase or when we're trying to execute a new project, right? I think because we listen to a lot of entities trying to present new innovations every week, right? A lot of presentations and folks trying to share their new capabilities. And I think one of the best things that you could do as an innovator is to partner with contractors that we work with, right? Because we use those contractors to execute our projects. And if you're able to validate a lot of the innovations, especially in the hardware, delivery of those projects, I think if you're able to partner with them and show the effectiveness and the capability, I think developers are much more inclined to look to adopt them, right? Working with contractors to bring up that TRL level is, I think, a good way to go.
Excellent. Thank you. So just to summarize, sort of on the grid side, there's a need to have a more coordinated approach, to share more knowledge and data as well. It's good that there's a lot of support from you guys around innovations, and there's the right infrastructure in a way in place to support this. And and it's really for innovators for startups to get engaged and then maybe also have the right partnership and look at the right moment to get into the projects. I want to move on to the floating wind. It's a technology that has a lot of promise. It will unlock huge areas that in the moment are not really accessible for offshore wind. It will also enable new markets to enter or new regions like West Coast, for example. But in the moment, cost is still very high. It is really not where fixed offshore wind. So what do we need to do to really accelerate the deployment of floating wind? What is the sort of technology that we need to see to to make it commercially viable. And then obviously you just installed the largest floating wind farm in Norway at Tampen, so there's probably a lot of learning from there. But where are we in your view with floating wind?
Yeah, we're very proud to have the world's largest floating wind park, but it's only 11 turbines, so hopefully it won't stay the largest for a long time, but at least we have been able to do that, we're definitely proud of that. I do think one of the first feedbacks I got when I asked the project director there on, what's his main feedback was, do as much as you can on the dock, right? I think their experience was there was too much pushed out in the ocean to be done there. So if anything, development technology-wise that can help, kind of pre-commission as much as possible on dock before coming out in the sea. That was his number one feedback to me when I asked him. But then I think this is definitely a very interesting area, and I think, of course, here we're not at the size turbine, of course, as we're with the bottom fixed ones, but there probably will be development in that direction to make also these produce more power and make them more financially viable, these projects. But I'm just throwing it out there. What about floating without mooring? Can we explore some type of DP system that would, just looking at some of the major costs, right? Now I'm just dreaming, but
well, it's innovative, yeah. That's the whole thing. So free floating, maybe it's a term.
Yeah.
Don't lose the wind farm. Maybe it's going to Asia. No, I think that's a very interesting area. It's one of the areas that I agree with Colin said before. We need maybe even more research projects and incentives in that for floating offshore. There are a number of designs and models for, and for the mooring systems and the platforms. But I think that we were discussing before about standardization, modelization. In floating offshore, I think we are one step behind. So we are still trying to understand how the design is working, if we can improve it. So I think much more effort in R&D and much more incentive are needed. I like to think it's a good time for this. I think in general, especially in the US, we are seeing how there are a lot of initiatives. I'm just thinking, for example, the hydrogen hubs has been a good example of how to deploy, not just R&D, but deploy commercial solutions. But we have seen many other programs looking into how to improve, electrolyzers and some other components that require more elemental investigation, elemental research. I think for floating, it's essential to have some kind of support from government and incentives to develop different designs and move quicker.
But then maybe go. You. I would just add one. I love everything you just said. I think it would really help floating a lot if we could get from an architecture perspective, right? If we could get it closer to what fixed is, right? Where you have 4 main architectures that you would use. If we could get float, because there are a lot of different floating designs out there, architectures out there, and at different levels of readiness, right? And fully agree. Yeah. I'll let you keep going.
No, and then in a way, connecting to this, it's sort of floating is quite well suited for standardization in a way. But then also, is there not a risk that we are sort of keeping validating and testing and demonstrating and do we not just need, because Tampen, it's 11 turbine, but it's pre-commercial in a way, and when are we moving to fully commercial? Can we not just do it now? Do we have enough? Because I think in a way you just need to do it to a certain extent. You just need to, and then by just going commercial, you will then probably also look at a lower number of concepts that will actually be at the stage of commercial, because otherwise we are keep testing new concepts and we not get out of this loop. I don't know, any views on this?
I agree. I mean, the thing is that Iberdrola, we are developing one project in UK, a floating, I think it's 1 turbine or 2 turbines project, but still we want to be first, second movers, I would say. But to the extent, if you think about offshore wind projects, they have to be gigascale. There's no way you can do like a 100 megawatts offshore wind project anymore. That's not going to be competitive. So we need to have a little bit more understanding about the economics and the technology. And then when you have that, my point of view is that it's a question of supply chain and how you work with the supply chain. That's a similar problem with the one that we have today with fixed bottom offshore wind. So how you develop the supply chain, how you develop all the tools, all the ships, all the logistics, very similar. So we can work in parallel. We can work to develop those and to address the challenge that we had in conventional, bottom fixed offshore wind. But in parallel, I think we need to investigate more with some research projects in the floating. But at some point, I agree with you. At some point, we have to say, hey, let's develop something fully commercial, because if not, we can be testing all the time. So that's that.
I would add, because Ellen referenced a little bit of it a second ago, is innovation on the port harbor logistics. The feedback you got from your project director on that is the basis of floating, right, and making it work is making sure the facilities are there and the capabilities are there to be able to do everything you can do at the port. So that's innovation needed there too.
Yeah,
I think it's an important differentiator, right, between the bottom fixed and the floating, is that you're actually, when you have it bottom fixed, you can put it there and you build on that. When it's floating, it's nothing stable. So he says, I think he called it was Olympics in logistics to put out those 11 turbines, right? It was a massive, the hardest part of the project, he said, was the logistics offshore, putting this all together. And it was also connected to an offshore oil and gas installation, in addition, of course, where they had live hydrocarbons. But anyways, so I think kind of respecting and understanding, how can we do as much as possible and innovate and expand what we can do onshore before we pull it out in the ocean. I think it's a major mover on that one. And then, of course, permitting here also, I think, will definitely be could be a challenge, or could take quite a bit of time, because it's a bit different than what we see, I think, in the bottom fixed.
Mm-hmm. So innovation around infrastructure, or scaling up infrastructure, more investment into infrastructure is critical.
Yeah, and how we think of the modular parts here, right? What can we put together, and perhaps, how can we, as easy as possible, assemble it offshore and in as large bits as possible, I think. Yeah.
Are there particular parts, components that you would think are particularly important to improve, to innovate? I don't know, mooring system, maybe. I don't know, on the turbine side, do we need more innovation on turbines to be more specific for floating? I don't know.
I don't think it's happening, to my knowledge, but I think there is a need for that. It's interesting. So I was listening to I think Yao Fang presented a project on stabilizing offshore wind platforms, and he was trying to, they developed a way to do that, but the issue that he had was there were so many different types of offshore platforms that it was difficult for them to come up with a way to solve the issue. So I think there is a need for innovation on the turbine side, but what changes should they make with there being so much variability on the different types of design is the question that I have, right?
So in a way, from this perspective, standardization was maybe even accelerate innovations because you reduce the number of variables, and therefore you can focus more on and then help innovations to really accelerate maybe.
And I guess also just example again, right? Floating. Now we're having these bottom fix we have 40 to 60 meter water depth about our beacon lease. Then the high wind Tompen that we're talking about in the North Sea is about 300 meter water depth with mooring. And the California one is 1,000 meter water depth. So just the physics of that, right, makes it totally different concepts. So it's also, yeah. So that's why I'm thinking, can somebody figure out how we could get away with mooring altogether?
Comes back to the free floating concept.
Yeah,
Yes, I like this actually.
Yeah.
Another aspect probably is the cable. So this is not going to be a cable that you just put on the ground, or in the subsea in the sea, and you say it has to be flexible. You need to analyze materials. It has to last for 30, 35, 40 years. So that's why I think a lot of testing in that line is also needed. Apart from the mooring, I mean the mooring systems and the stabilization of the platforms, those are really really important. But also the how we connect all these turbines, and then from there to the shore. So that's another aspect, different and challenging also.
Excellent. Let me just sum this up a little bit. Let me try to sum it up. So we heard it's important to move things onshore, so we need to do more onshore. We need to have the right infrastructure in place and investment. There's a need for government support, more need for testing and validation, and then maybe look at as free floating, some very innovative concepts. But yeah, a lot to do to still and to get floating done, and lot of need for innovation. That was really interesting. I really enjoyed this discussion. I hope you too. I want to wrap up, and just want to ask you to join me thanking this panel for this very innovative and informative discussion. Thank you very much. Excellent. And then I think I hand over to Lindy for some closing remarks.
Hopefully this microphone is on. Can everyone hear me? Good enough? Okay. Well, we did it. We made it to the closing. So I'll be brief because I know it's been a long day and a lot of folks have some travel to do and things like that. So as a reminder, I'm Lindy Heiss-Dutton. I am now RDC's Executive Director. So I want to thank all of you for your attendance today, whether in person here in Brooklyn or joining us online. I'd also like to thank NYU's Tandon School of Engineering for hosting us these last 2 days, and New Lab for hosting us at the really exciting tech showcase last night. As I mentioned in my opening, this year marks 5 years since the founding of the consortium, and as one of the newer members of the team who just joined in January of this year, I've had the opportunity to reflect on all the great work that the consortium staff, board, and members have accomplished to date, and I leave today with a renewed excitement to help build our vision for the future. But we can't be successful without all of you. It's been really inspiring to see the success of the consortium and the collaborative processes that have allowed us to support all the great work that we've been discussing these last 2 days. You've shared your insight on topics such as transmission and grid, operations and maintenance, coexistence, autonomous systems, floating offshore wind, supply chain, and our visions for supporting innovation. We've also had insightful discussions on industrialization and standardization and how we can balance market needs and supply chain limitations, as we heard echoed on the last panel. Again, I welcome your input and ideas on how the consortium can support these areas in the future. We're here to help our collective goals move forward. As I said yesterday, the consortium, through the support of our members, our board of directors, and our research and development committee, has been able to leverage our collaborative mindset and support over 50 R&D projects to date. And as we've noted, this is only a fraction of the proposals that have been submitted and highly scored across our solicitations. We've demonstrated there's a clear need to support R&D and a clear interest from talented researchers to do this work. I hope you leave the symposium with a sense of the type of work we support, and I hope you were able to see firsthand the high-quality, cutting-edge, essential work we've supported. And I hope you walk away with some ideas and inspiration for the future. Excuse me. For those of you that are interested in research and innovation, I'd like to remind you that now RDC does have an open solicitation currently. We've partnered with Innovate UK to release a joint US-UK solicitation to support international research partnerships, supported by funding from our state members from Massachusetts, New Jersey, and Maryland. I encourage you to visit our website for more details, including the challenge areas for this solicitation. This afternoon and at last evening's reception, we also had the opportunity to highlight the first cohort from the Offshore Wind Innovation Hub, which, as a reminder, is a partnership with Equinor BP, the Urban Future Lab at NYU, and New York City EDC. As Julia noted in today's hub panel, after today's hub panel, we look forward to starting the search for our next cohort in 2024 and anticipate more details coming out early next year. As we look forward to the future of Now RDC and how we can build upon the vision of our founders, we've been identifying novel ways to support R&D and innovation in the future. We welcome your insight and your guidance on where we should focus our efforts and where you all see the need to dedicate our resources. We value the input of our members and our broader community, and if you're interested in becoming a member or getting more involved in Now RDC's work, please let us know. I know we are all incredibly busy, and I appreciate you taking the time to join us for this symposium. I hope you have found your time with us this week valuable. I've heard a lot of people come up to me and to other members of our staff and share their highlights of the symposium, that they valued learning about the projects we've supported and hearing the perspectives of the researchers and innovators, that they valued hearing the panelists have open discussions and varying perspectives and sharing learnings across portfolios. They valued the ability to slow down a bit and to focus on the topics with limited side distractions and meetings. And they value the opportunities to join together in person under a common goal and the insights and ideas that often stem from conversations over coffee. Thank you all for your participation in this event and for your dedication to the work we do. We're working diligently to help build this new industry in what I hope is in an equitable and responsible way. We leave with a collective call to action to test and validate and new technologies and innovative strategies support offshore wind. In a moment, I'll turn it over to Walt to share his closing reflections, but I'd like to sincerely thank all of you for attending the symposium and for your support. Thank you to the moderators and the speakers, and for allowing us to highlight your work and your expertise. And once again, I'd like to take a moment to thank Now RDC's outstanding staff for all of your hard work and dedication to make this event a success. Special thanks to Corey, who last I knew was hiding in the media box. I don't know where she is. She's around somewhere, I can guarantee. Special thanks to Corey for her leadership and all the planning and coordination. I also want to thank the NYU team from the Offshore Wind Innovation Hub for not only hosting us here at NYU, but working closely with Now RDC over the last few months and over the last few days to keep everything running smoothly behind the scenes. We couldn't ask for better partners. And I'd also like to note that the location for next year's symposium is to be determined. So this is only the second time that we've been able to host a hybrid symposium with an in-person event after coming out of COVID, with last year's meeting being in Boston at Northeastern. We welcome your thoughts and ideas of where we should go for 2024. Thank you.
Hi, everyone. And thank you, Lindy, for letting me close this great symposium up right now. I'm Walt Musial. I've been involved in this consortium from the very beginning. I was part of the NYSERDA proposal that came through, so I've been doing this for over 5 years now, and I had the pleasure of serving as a senior technical advisor through the different transitions that have happened when this first gained its foundational funding from the joint collaborative between NYSERDA and the Department of Energy when they first garnered the $41 million to start this. And then the consortium grew by getting membership dues and state support to something more like 53 million, and then that's resulted in all of you being here and the 52 projects that have emanated from this. So I wanted to just say that it's an honor to be here and to close this symposium today and to maybe reflect a little bit on how far we've come here. And I also want to thank Lindy, who is sponsoring this now, the executive director and the staff. I know that's maybe redundant now because you just did that. But Corey back? Because, I mean, let's just give Corey a round of applause because I think it's... The truth is, Corey really muscled this into place, and I don't want to diminish the efforts of the other staff here that worked on this, the Now RDC board and the R&D committee, and the work that Jan and Olivia did from the Carbon Trust, and then the other staff, really Julian, Mel, Christine, who contributed widely to doing this, and also to all the projects that came here to report. So this has been a big effort, I think, and I wanted to recognize, from my perspective, the unique role that the Now RDC plays nationwide, because this was originally formed from an inspiration that DOE had to dedicate some of their money to projects that they weren't maybe able to support as well as something from the private sector. And then this was solicited through a competitive solicitation. And now RDC really serves a unique role in the industry right now. And I just want to recognize that because I don't think, Lindy's not going to brag about herself, but I can do that maybe for her. The consortium's technology agnostic, and that means really they're honest brokers for the industry. They don't have an agenda to commercialize these technologies. This is, but it's something that if you're in a private nonprofit, you can do things a lot faster and respond a lot better than you can if you're part of a large government bureaucracy. So this is something that they've been able to accomplish. And then when Carbon Trust came in and really centered this toward, and I think through the Offshore Wind Accelerator program, they learned how to adapt an organization like this toward the end users, which is really the board of directors. So as the industry has evolved over the past 5 years, the consortium has evolved as well. And so together, we've written 4 roadmaps that each one adapts the needs of the industry, and then the board and the R&D committee select the projects that go into the next solicitation. So we've done that. I won't really repeat all the stuff that you just did because but out of the 52 projects, it's very diverse how it's been divided between the grid, the environment, the resource, and everything. And those projects are embodied in the people that sitting right here. Thanks for sticking around till the end here. And as far as the future is concerned, I think I won't really speculate beyond what you did, but I think we should recognize there's multiple opportunities that could still exist beyond the 3 pillars that DOE originally set up in developing this consortium. And so I think it's wide open. We've seen state solicitations, and you mentioned there's a solicitation out currently right now, and there's probably one coming out for floating soon. We're working on a joint industry project, and I heard it mentioned in the previous panel that maybe that's something we could do where the developers don't always have to be siloed into their own world, that we could work together to find common areas where research is appropriate among all the developers, and there could be a sponsorship there. And we're working on one that Yorgos, my colleague from NREL, reported on earlier yesterday, where we're looking at the long wake effects among all the wind farms in the Atlantic, and no developer can do that on their own. They can't assess that problem and give the guidance to the Bureau of Ocean Energy Management that's necessary in order to accommodate the next leasing. We have to do that as a group. But there's probably dozens of ways that we could all work together through projects like that. And I can tell you from NREL's standpoint, we can't do that either because we're constrained by the complex contracting that we're subject to. But when we partner with Now RDC, we can do that together, and we're working on that. This is our first attempt to do a joint industry project, and I think we're well on our way to success in that, and we're looking for ideas on what should the next one look like. And it doesn't have to be NREL, but I think Now RDC is a great focal point for that kind of stuff. So now. I think just to kind of close out here and wrap up, I just want to acknowledge the situation that the industry is facing right now, and I know that a lot of people are anxious about the climate that you might be seeing. And I've been in this industry 40 years. I've been in offshore wind 21 years, and I can tell you the economic climate right now, it can maybe create some anxiety among people because what we've seen is high inflation, high costs going up. This isn't the worst thing that's happened to offshore wind since I've been doing it, and it's probably not going to be the worst thing going forward. So get ready for a wild ride. We're doing something that is probably, in my opinion, probably one of the most ambitious things that the world has ever done, which is to change the global energy economy to complete decarbonization, and we're doing it fast. And so there's going to be bumps in the road as we go, but I think we're all signed up for that right now, and we should be ready to follow through with that because we need to do it. Offshore, we can't do that without offshore wind. The states know that. They've all signed up for this. And when we've seen all these project cancelizations over the past, say, few months and last year at least, the states have stepped up and adapted and recalibrated their systems to accommodate this. And so we're going to see this move forward again. I don't know what it's going to fully look like, of course, but it's we're I think doubling down on this, and we're going to continue to develop an industry that will support. We're not looking at 30 gigawatts by 2030 necessarily. What we're looking at are state commitments that are 115 gigawatts, if I add it all up, and I have, by 2050, and that's probably a low number for what we have to do to decarbonize the coastal states of the United States. And really, finally, I want to just wrap up by recognizing that there's a huge role that this group is playing right now because we can't do this without innovation. We have to look toward the consortium and other groups like this to innovate. And I don't want us to get caught up in this one-dimensional thinking that upscaling is the only way to innovate. Innovation space is very big. If we upscale, we're kind of deciding to not innovate in other areas. I think we have to think broadly about what's best for the industry and how to build the supply chains that are necessary to achieve these deployment goals. And that's what's most important. And the work that you're doing right now is very, very important. So thanks for what you're doing, and thanks for all the time that you've spent doing this. And I hope to continue doing this. See you soon. Thank you.